video for the baggage handling, load balancing, and system optimization team. The team consists of Joshua, Benjamin, Trevor, Kaushik, Mary, Logan, and Anna. Our project sponsor is Charlotte Douglas International Airport, and our project mentor is Dr. Lim. First off, looking at our problem statement, we want to analyze current and future load balancing information and develop algorithms for automated RC1, RC2 load balancing. The goal through doing this is to build a simulation model that replicates the operations of the current CBIS system. This will include conveyor belts, speeds, capacity, entry and exit points, and several other aspects. Data gathering will also be done for the physical aspects and arrival rates, loads, and so on. Looking here at the picture, you can see where our RC1 and RC2 lines go from the left to the right. In the middle, you can see that vertical sorter where the lines cross. This is where we're going to go from our manual to automatic switch, which we'll go into more detail next. So the project deliverables that are important to consider are our ARENA simulation model replicating the existing baggage system. There are various different data analyses, including creating data schedules and jam data to replicate this vertical sorter condition. The most important aspect of this is for the model to include this data to help the vertical sorter move from the manual to automatic switch between our RC1 and RC2 lines.
Two of the key features of our ARENA model are its seasons and induction points. Rather than developing solutions based on the typical seasons of the year, our team used 3 seasons that were determined based on trends in the bag arrival data. Seasons 1 and 3 contain the majority of the fall, winter, and spring, while Season 2 represents the summer months. There are 3 main sections of induction points that are included in our ARENA model. First are the RC lines, which is where the international flights arrive. Next are the IC lines. This is where the ticket counters for departing preferred passengers are located. Lastly are the TC lines, which are the ticket counters for departing passengers who are not preferred. In order for our ARENA model to operate correctly, schedules needed to be created for each of the induction points. This is an example of the RC line schedules. A statistical analysis software called Minitab was used as a tool to make season and schedule recommendations. 1 full year of bag arrival data broken down by day was inputted into the software to be analyzed. In the photo on the top left, the comparison of each season is displayed. It was concluded that all 3 seasons significantly differed, with Season 2 seeing the most bags and Season 3 observing the least. In a similar way, days of the week in each season were compared. The image on the bottom right shows the output of this process. The days that do not share a letter are significantly different. Therefore, after further analysis, our team was able to determine that Saturday, Sunday, and Monday through Friday would be 3 separate groups. This methodology was used so that schedules could be made in a more manageable and efficient manner. This is a week-long schedule for the RC lines during Season 2. Notice that Sunday uses its own schedule, Saturday uses its own schedule, and Monday through Friday operate on the same schedule. This information is then inputted into ARENA so that it can accurately represent the real system. This process was done for each induction point and each season.
So out of gauge and jam data, we had from January 1st, 2019 through August 31st, 2019. So we ended up separating it from Season 1, which is January 1st to May 1st. And then we have Season 2 from May 2nd to August 31st. We ran regression models with date versus total jams and induction total versus total jams, but there was no correlation between jam data and out of gauge data. We ran more regression analysis using data versus total jams and induction total versus total jams, using Season 1 and Season 2 and comparing those to the previous analysis that we had done, and it showed that there was still no correlation. For the daily baggage data, we separate into 2 seasons as well. For Season 2, there's quite a bit more bags that are going through the system, and we found out that there is a correlation between the induction total and the number of jams that will occur. So for Season 2, we can expect more jams since the induction total is higher than Season 1.
So this is our ARENA model. So this is a software given to us by Rockwell Animation Studios, where we're able to set up real-world processes and actually map them out using our technology. So here you see a widescreen view of the Charlotte Douglas Airport baggage system for international arrivals and receiving at ticket counters going towards X-ray machines. If we zoom in here, we can start seeing that we have bags flowing through. Now it'll be going a lot faster and it'll be hard to see a smooth flow. That's because it's going at simulated time, not real time. If it was real time, it would be going a lot slower. And this is a great example. to start talking about different types of data inputs. So we're dealing with two different types of data inputs here. We're dealing with regular size bags and out of gauge bags. Out of gauge are these larger boats, whereas in gauge are our smaller present size packages. That's to keep it colorful and make sure that we can see what's actually going on. Now, if we start going over to where we're getting the magic done, we can see here in our modules how all of this is beginning. So in Arena, you use modules to simulate what you're actually trying to get done. So here is where we're actually creating entities, like those bags, which are presents in the animation you just saw, to then go in and be decided if they are to remain the same as in gauge or to be swapped to that ship size. Then we can start talking about, is it supposed to be an RC1 or RC2? That's the reclaim conveyor belts, and that's where we're starting to see what our actual problem is solving how we're supposed to keep our bags up or down using the vertical sorter to reduce jams along the line. The vertical sorter is a cantilever type apparatus that is either up or down to send bags to either RC1 conveyor belt or RC2 conveyor belt, which have different resources on each, different lengths, and all sorts of different variables worthy of keeping track. Once we start looking at that, we can start looking beyond just there. So you use these types of Arena modules for transfer. These light greens are what we are actually using our conveyor belts. So this is what you saw those bags running on those tracks. To move down, go through, actually we have the ability to simulate jamming and waiting for bags to find areas so we can see if it's clearing out. Without any input of a schedule here in this vertical sorter, right now it's a simple either on or off for heavy load times. But without it, you will start seeing lots of jams. Here we see 3 jam, 2 jam, and we've been running for several hours already. We can zoom farther ahead and we can see that we're not going up in jams very much. That means that we're starting to see what we're supposed to see. Of course, we still have a few more weeks to finally get at that real data crux analysis and actually see what's supposed to be where we're getting. So we can hopefully, instead of these 7, 8 small numbers of jams, even lower. Keep it at this nice, cool, crisp 0 number of jams. All in order to make sure that we have enough resources for these CTX machines, those X-ray machines, to make sure that your bags are safe and not to overwhelm the system so your bags get where they're supposed to go.